that inequality. Now, I always have my students sing this song. When we're doing inequalities, what we find out is it doesn't matter what you do. You solve them pretty much the way you solve equations until you do one thing. The one thing you're not allowed to do and keep things the same is multiply or divide by a negative. So when I did this, a lot of people think about it symbolically as I multiplied by -1, right? When I took the opposite. Well, the problem is when I start flipping things, I have to flip something else. And we don't really see it in this situation. So I'm going to try or attempt to draw what that looks like. Okay. And what I would recommend you do is take something and put, and it's nice when you have the transparency, but you can put a less than sign on one side and a greater than sign on the other side. I just messed up your thing. But I'm going to put a little line under it if it's less than or equal to, greater than or equal to. So suppose, and we're going to do an easy one. Let's suppose we have, let's do this. Let's do x on this side plus 2 equals -1. Let's get a simple one. And instead of an equal sign, I'm going to put my less than sign. So symbolically what I have is I have -1 is less than x plus 2. Nice little inequality there. Now I'm going to do a two-stepper, but once you know how to do this, you can do a one-step really easy in 6th grade, right? Now, remember, same thing. We want to get our x alone. So we want to get rid of those two positives. What are we going to do? Add the opposite to both sides. Oops, I didn't even draw it. So let me get my drawn. -1 less than x plus 2. Okay, so I added 2 negatives to both sides to get rid of these ones on my x side, right? So symbolically, plus -2 plus -2, draw a line. Now I'm going to end up with -3. I've got my 2 0 pairs, right? So circle those up. That's 0. Might as well ignore it now. -3 is less than x, and then that's 0. So we're in good shape, right? X is on the right. So if you've taught them a trick about how to like shade the way the arrow points, it doesn't work so good when x is on the right. But we need to be able to solve these. So if we wanted to, we could move things around. But what we really want to do is see how to get this to be a different sign. Say I want these to be positives, or I want to flip this sign. Okay? Well, I can do a couple things. I can teach my students this, like the alligator trick. The big part is open to the x, so if I flip this around, the big part is open to the x, and then I can move things around, and it makes it that nice inequality we like seeing. So you can do that. But symbolically, what can we do? Well, I can add a -x to both sides. And now my x is over here, right? So -x. And this is a 0 pair. X is there. Oh, no, I'm on the wrong side. So I'm going to add 3 back. See, we should have picked our x side to begin with, huh? There we go. Add 3. Add 3. See, we can do this all day as long as we don't break the rules, right? So add 3. Add 3. Plan ahead better next time. That's my suggestion. And so then we have our 0 pairs. And now we have -x is less than 3. All right, let me draw this out. Try to be a little neater. All right, there we go. So we have that -x is, so instead of that, what we've done is we have -x is less than 3. But again, we want to know what x is less than. How do we do that? Well, I need to flip this, right? So if I flip this, guess what I have to do? I have to flip this, and I have to flip these. And then I get, instead of x is less than, I get x is greater than -3. All right. That's what I had here, but this is why it works. Now, you say, Bianca, or as my students say, Mrs. Coker, why did you all of a sudden start flipping things? Well, if it had been an equal sign and I flipped it, would you have noticed the difference? Not really, right? So You might want to do that equal sign in the middle, like on a little piece of an index card, all the time, so that when you get to inequalities and you start flipping, you'll be set. You don't have to flip though, if you're okay with your positive x's being on the right. If you're going to do that, then you need to make sure you use test points to shade your number line and not do some trick. All right. Whew, that's a lot. I hope it's enough for you to be able to help your students model and solve one variable equations on both sides of the equal sign in 8th grade, on just plain old two-step with variables on one side in 7th grade, and just those lovely little one-step equations in 6th grade. If you need any help with this, remember Region 10 is here to help. Have a great day.